Welcome to this video. So what we're going to do is we're going to look at the nature of radioactive radiation. Our learning intention for today is to understand the nature of radioactive radiation, making specific reference to alpha, beta and gamma particles. So before we start looking at radioactivity properly, we need to look at the atomic structure that you would have learned at Junior Cert. So the simplified version that you would have learned at Junior Cert is you have a nucleus, and inside the nucleus you have neutrons and you have protons. Protons are positively charged and neutrons have no charge. And then electrons are found in the shells surrounding the nucleus, and electrons have negative charge. So for radioactivity, we'll start with a definition. So radioactivity is the spontaneous breaking up of unstable nuclei with the emission of one or more types of radiation. And the word unstable is very important there in your definition. It simply means giving off of rays, and something that gives off rays or gives off radiation is said to be radioactive. There's three types of radiation that we're going to look at in this lesson: alpha radiation, beta radiation, and gamma radiation. So to begin, alpha radiation, an alpha particle is a group of two protons and two neutrons that are stuck together. And two protons and two neutrons stuck together, if you think about that, that represents the nucleus of a helium atom, which I have identified down here. Alpha particles will only ever be emitted from an unstable nucleus, and that is very important to remember. So if we look down here at our diagram, we have a large unstable nucleus, and that undergoes radiation to give a smaller, more stable nucleus with an alpha particle having been released. And we can see that this is an alpha particle here due to the two red and the two blue kind of balls indicating two protons and two neutrons. Alpha particles have a low penetrating power, and they are stopped by a few centimetres of air or a thin sheet of paper, as indicated in the diagram here. It's important to know an example of elements that emit alpha particles, and an example is americium-241, and this can be found in smoke detectors. So next we're going to look at beta particles, and beta particles are simply electrons. Beta particles are formed when a neutron from the nucleus of an atom is changed into a proton and an electron. And as you can see, I've written that down for you there now on the slide. We need to remember that it's the nucleus that this is happening in. So the proton belongs in the nucleus, but the electron doesn't. So that means it's making it unstable. So the electron is ejected from the nucleus. So we can see that down here, that we have a large unstable nucleus of our element, and that converts into a smaller, more stable nucleus with a beta particle having been given out. Beta particles are lighter than alpha particles, so if they're lighter, that means that they can travel further, so they penetrate more than alpha particles. And beta particles can penetrate up to 5 millimeters of aluminium. So the beta particles will go through air, they will go through a sheet of paper, and they will only be stopped by 5 millimeters of aluminium or something thicker than that. You can see that here in this diagram. This is a beta particle being stopped by a sheet of aluminium. As with our alpha particles, you need to know an example of an element that gives out beta particles, and that is the isotope carbon-14. And carbon-14 is used in carbon dating, which links up with subjects like history. The last type of radiation on the Leaving Cert course is gamma radiation. And gamma radiation is basically high energy electromagnetic radiation. So gamma energy is often considered as waves. Gamma radiation consists of no charge, and it's basically emitted by the nucleus to lose energy. Gamma rays are very dangerous. They have a very high penetration power, so they can only be stopped by a thick slab of lead. So gamma particles will pass through the paper, the 5 millimeters of aluminium, and only be stopped by a very thick slab of lead, making them very dangerous. An example of an element that emits gamma rays is cobalt-60, and it is used in the treatment of cancer. So this summary table here goes through everything that we've gone through in this video, including what's emitted from the nucleus. And I've also given an example of each radiation type. So this slide is really important to understand and summarises the whole video. So that's it for this video. Have a